Hi guys. So the question we have today is number 2. So the question asks, consider the curve given by y squared is equal to 2 plus xy. So for A, it says that you have to show that derivative y over derivative x is equal to y over 2y minus x. So to find that, first of all, I'll just write the original question. Right? We'll start simple and easy. And this pen's not working. Okay, here we go. A. We have y squared is equal to 2 plus xy. So we'll do this easy. You guys know how to find the derivative, right? So let's find the derivative. So 2y, but we have to respect dy over dx, so here we go. And then what's the derivative of 2? 0, right? So we know right here, this is what kind of a property? Not a property, it's a product rule. So we have to use the product rule. So for this one, it would be, so just to recall, you guys, what the product rule is, it's f prime g plus g prime f times f. We'll say this is f and this is g. So back here. So this is 0 plus dx over dy, which will be our prime, plus dy over dx times x. Alright, so for the next step, we know that these two need to be together, correct? Alright, so we'll subtract it to take it to the other side. So subtract dy over dx times x. Subtract. Sorry for the messy handwriting. Okay. Then, the next thing we have to do is that, so when we subtract these together, you know that these are like terms, right? So what you do is take out the dy over dx, right? And then you have 2y minus x. If you guys need a clarification for these, it's pretty simple. You subtract 2y minus dy over dx, you get two problems that have the dy over dx. Hence why we got negative xy. And then it's equal to y, right? So what do we have to do to get dy over dx together? You divide by 2y minus x. Yep. So divide. You get your answer as dy over dx is equal to y over 2y minus x, which is correct.
Alright, hey guys, so I'm going to be showing you how to do 2b. So b asks you to find all points x, y on the curve where the line tangent to the curve has slope 1/2. So the first thing you should do is to pay attention to what the question gives you. So the first thing I noticed is that it gives you the slope of the tangent line, which is 1/2. And as we all know, the slope of the tangent line equals dy over dx. So what you do is you plug in dy over dx as 1/2 from the original dy over dx equation you found in the previous problem. So this is how it should look. So it's 1/2 equals y over 2y minus x. Now, we have fractions on both sides, and your next step is to cross multiply because you can't do anything else with it. So you multiply 2 to y and 1 to 2y over x. And that should get you 2y equals 2y minus x. Now, I noticed that we have 2y on both sides of the equation, so they will both cancel each other out since you're subtracting 2y on both sides. And all you're left with is 0 equals negative x. And since x being the only variable left, you take x by itself. So your next step is to divide negative 1 on both sides to get x equals 0. Now this will count as your x coordinate. So you're halfway done with the problem. So your next step is to plug in your x coordinate into the original function because you're trying to find all possible points of the curve. So let me just erase this. Yeah. So again, plug in x on the original curve line of equation, which is y squared equals 2, well, let me rewrite it, plus x, y. So this is when you plug in 0 for x. And since you're multiplying by 0, the y will cancel out. And so all you're left with is y squared equals 2. And to get y by itself, you square root on both sides in order to cancel out the square. And you'll get y equals plus minus root 2. Now, since this counts as like 2 solutions, this will be your possible. So this will count as your possible points of the curve, which is 0 plus root 2 and 0 negative root 2. And that's it. These are all the possible points that you'll find in the curve.
Okay, so for part C now. So C is asking to show that there are no points x, y on the curve where the line tangent to the curve is horizontal. So we already know that where the line tangent to the curve is horizontal, we already know that the slope at that point, we know that the slope when the curve is horizontal is 0. So, and we also already know that the line tangent, so the slope of the tangent line at a point on the function is equal to the derivative of the function at the same point. So we're going to equal this to 0 because we know that when the curve is horizontal, the slope is 0. And we're going to equal it to the derivative of the original function, which we got was y equals 2y minus x. So we're going to multiply 2y minus x on both sides. So we get 0 on this because 2y minus x, anything times 0 is 0. 0 equals y. So we know that 0 equals y, and now we can plug it into the original function, the original equation. So y squared is 0. So yeah, so that was the original equation, y squared equals 2 plus xy. So 2 plus x and then 0 for y. So we know that 0, this is going to equal 0. So 0 equals 2, which is not possible. So that means that there is no solution. This just means that there is no point in which the slope is 0.
Okay, so for part D, we're going to find the second derivative of the original equation. We already found the first derivative, so we're going to use that to find the second derivative. So, it was dy over dx equals y over 2y minus x. To solve this, you need to use a quotient rule, so y is going to be our f value, and 2y minus x is going to be the g value. Okay? So, second derivative is equal to f prime of y. So f prime of y is 1, so it's just dy over dx times g, which is 2y minus x, minus f, which is y, times the derivative of g, which is 2 dy over dx minus 1, all over g squared, which is 2y minus x squared. Okay? From here, you have to distribute the dy dx to here, and you need to distribute this y into this set of parentheses. So, I'm going to need more room, so I'm moving to this side. So from there, you're going to get 2y dy over dx minus x dy over dx minus 2y dy over dx plus y. Okay? All over 2y minus x squared. So we see that we can cancel out these two things, and then we are left with negative x dy over dx plus y over 2y minus x squared. Okay? So from here, we see that we can add these two things. But to add them, we need to... Sorry, wrong step. Okay. So we cannot simplify any further because we have this right here. So since we already found dy of dx, the first derivative of the original equation, we can just plug it back in from problem A. It's y over 2y minus y. So I'm going to write it at the top. So it's going to be just negative x, and you're going to plug in for dy dx, which is y over 2y minus x plus y all over 2y minus x squared. Okay? So, from this problem, we are now trying to add these two things. I'm going to use the next page to do so. It's the same thing. So, to add them, you need to have the same denominator. So I'm just going to rewrite this as negative x over 1 times y over 2y minus x plus y over 1 over 2y minus x squared. It's the same thing from the other problem. It's just that I added the denominators to make this easier to solve. Okay? So you get, when you multiply these out, you get negative xy over 2y minus x plus y over 1 over 2y minus x squared. So, still you need to multiply this by 2y minus x over 2y minus x so that you can have the same denominator on both sides and you can add the fractions together. Okay? So what you will get from that is negative xy plus y times 2y minus x over 2y minus x, all that over 2y minus x squared. Okay? So now we have to simplify this more by multiplying the top fraction by the reciprocal, so dividing by multiplying, which you will get, sorry, I'll just use another page here. Sorry, before that, you have to distribute the y from the other equation in the back. So you're going to have negative xy plus 2y squared plus negative xy over 2y minus x over 2y minus x squared. Okay. From here you can cancel these two things out, or sorry, combine them, and you're going to get negative 2xy plus 2y squared over 2y minus x over 2y minus x squared. Okay? And then we're going to multiply by the reciprocal, just one. Okay, so you're going to set this up as negative 2xy plus 2y squared over 2y minus x times the reciprocal, which is 1 over 2y minus x squared. So, you multiply directly across and you get negative 2xy plus 2y squared over 2y minus x to the third. And that's the final answer. It's the second derivative. That's your final answer. Thank you.